Good morning, students. Welcome to physics class. We are in practical session. In the last class, we studied about vernier calipers, and by using vernier calipers, we measured internal diameter and depth of a calorimeter or a beaker, and after finding internal diameter and depth, we learned the procedure how to calculate the volume of the given beaker using this vernier calipers. In today's class, we are going to learn about screw gauge, and by using this screw gauge, we are going to find the diameter of the given wire and the thickness of the given sheet. So let us start the procedure. What is this screw gauge, and what is the purpose of using this screw gauge, and what is the difference between vernier calipers and screw gauge? Let us learn this first. How the screw gauge appears. So this is the appearance of screw gauge. The important difference between screw gauge and vernier calipers is vernier calipers can measure minimum reading of 0.01 centimeters, that we learnt in calculating the least count of the vernier calipers. Now by using screw gauge, we can able to measure the minimum reading of 0.01 millimeters, that is the least count of screw gauge. So students, we can easily measure the reading of 0.01 millimeters using this screw gauge. So screw gauge gives the accurate reading when compared with vernier calipers. So what are the important parts of this screw gauge? So this is the instrument screw gauge. Here this stud, which is a fixed portion of this screw gauge, and this is screw which is used to rotate, and any object whose thickness is to be measured, we can place that object in between these stud and the screw. And when coming back to this measurement part, we can see the internal readings. Here I can able to see 0 and 5. Meanwhile in between this 0 and 5 we are having a few more subdivisions. These readings are called as pitch scale readings. Like we have main scale reading in vernier calipers, like that we have pitch scale reading in screw gauge. And here, like vernier coincidence in vernier calipers, we have head scale readings. Head scale readings are framed on this circular part of this screw gauge. So this is pinch scale reading and this is head scale reading. And this thimble is used to fix this object in between the screw and the stud with the help of this ratchet. So here ratchet can be rotated, and we can easily make this object to fit in between stud and the screw. So let us see how we can measure this thickness and the diameter of given object using this screw gauge. Before going to start our experiment, let us know the procedure of finding out this least count of this screw gauge. Least count of the screw gauge can be determined by this procedure. First one, linear scale division, means how much this screw is rotated so that the head scale will rotate, and the distance covered on this pitch scale, that will be called as linear scale division. I will show you what is this linear scale division. Before that, let us see this procedure in detail. So distance moved is that linear scale division, and for every screw gauge we can have 100 circular scale readings. So least count can be calculated as 1 millimeter by 100, which is 0.01 millimeters, and if you convert it into centimeters, you will get 0.001 centimeter. Now I will show you how to find out the least count of the given screw gauge. In this simulating video, if you observe, here I am trying to move this screw to displace this to 1 millimeter. So if I rotate this one, it will displace 1 millimeter, and here how many rotations I am using to displace this 1 millimeter is 1 rotation. So that will give the pitch of this screw gauge. I will show you again. Here it is exactly on the reading of 10 on this pitch scale reading, and I am trying to rotate this 1 millimeter. So it is moved 1 millimeter distance, and here number of rotations done by me to cover this 1 millimeter is 1. So distance moved by number of rotations is equal to 1 millimeter. And if you see this while doing the experiment, you can able to see here I am having 100 head scale divisions or 100 circular scale divisions. So pitch of this screw by number of circular scale divisions gives least count. So 1 by 100, which is 0.01 millimeters. That is the least count of this given screw gauge. So if you know how to find out the least count of this screw gauge, it will be easy for you to find out the diameter of the given object. That is first step. Now second part of this screw gauge is measurement of error. What is this error and how to rectify this error using this screw gauge? Every measuring device has some error, but some of the devices we can't able to rectify, and some of the devices we have the chance of rectifying that error. So in this screw gauge, what is the error of this screw gauge and how it can be rectified? Let us check once. Before going to find out that error, make sure that there is no object in between the stud and the screw. Then rotate this so that the stud and the screw will be in contact. Once it is in contact with each other, if the screw gauge has no error, the head scale 0 should coincide with this pitch scale horizontal line. If you observe this, that coincidence is not happening properly. Here the head scale 0 is above this horizontal line. How much above is this horizontal line? Means here it is 2 divisions above. This rotating 0 or the circular scale 0 is 2 divisions above this horizontal line. So the error is negative error, and we have to do correction for this. Correction can be done positively. Means here whatever the reading we are getting after keeping the object, that reading should be added by 2, added with 2. So since that head scale 0 is above this horizontal line, how many lines it is above this horizontal line? That many number of lines should be added to the reading of this head scale when the object is placed. That is called as error. In some of the screw gauges, this 0 is below this horizontal line. So count how many lines it is 0 below this horizontal line, and that many number of readings should be removed from the actual reading of this circular scale. So here this 0, head scale 0 is above this horizontal line, so we have to add the reading, we have to add this 2 to the actual reading of this circular scale. So that is the procedure here you have to remember. Okay, so I hope you got clarity about this error. Here the error is called as negative error and the correction is positive. Similarly, when the 0 is below this horizontal line, the error is positive and correction is negative. So don't get confused between positive and negative errors and its corrections. One way you can remember, this 0 is above this horizontal line, so how many lines it is above, that should be added to the given reading. So that is the point here you have to remember. So I hope you understood this correction part. If you are familiar with this correction part, then we can go with the measurement of the given object using this screw gauge. in this video, if you observe clearly, this 0 circular scale 0 is 3 lines below this horizontal line. So as it is 3 lines below this horizontal line, error what I told here is positive and the correction is negative. So here it is showing 3 lines below, so error is positive and correction is negative. So we have to consider this correction while measuring the thickness of the given wire. You can see this measurement of error clearly in this zoomed video. So horizontal 0 is here and the 0 is here, and the circular scale 0 is here and the horizontal line is here. So the difference in the position of this 0 and the horizontal line is 3. That's why it is clearly mentioned that error is positive and correction is negative. Now we are going to measure the thickness of glass plate. So what are the materials required for measuring this thickness of this glass plate are screw gauze and glass plate. So please observe clearly how this glass plate is inserted in between the screw and the stud. Once it is getting inserted, observe the reading on this pitch scale. It is showing 0, 1 and 2. So 2 millimeters. And this reading gives circular scale reading. I will show you back. This gives the circular scale reading, which is 60, 65, 66. So let us go through the tabular form of this measurement. The scale reading is 2 and 66 is the reading, head scale reading. So 2.66, and here after doing the correction we will get the actual reading 2.63 millimeters. That is the thickness of the given glass plate. Similarly, we can measure the thickness of the given wire using this screw gauze. So let us see that procedure also. This is screw gauze and the wire whose thickness is to be measured. Same procedure will be applied. Insert the given wire in between the screw and the stud, and the reading shown here is 0, pitch scale reading is 0 and head scale reading is 48. So after considering this circular reading and the head scale reading, you can multiply this with the least count, so that after finding out the proper error value, including this proper error value, you will get the reading, the thickness of the given wire as 0.45 millimeters. Now we will apply the procedure what it is shown in the video, and we can find out the thickness of glass plate and the thickness of given wire using this screw gauze. So let us cross check once again the error value of the given screw gauze once. So we can make this in contact. So here it is 2 divisions above. This circular scale 0 is 2 divisions above. So correction is positive and error is negative, opposite to the reading what it is shown in the video. So correction is positive and error is negative. So whatever the readings we are getting, we have to add to this circular scale reading. Okay. So this is error. And now let us proceed by placing this glass plate in between the screw and the stud. So once it is in contact with this glass plate, we will get the readings readily. So here pitch scale reading is 2 and head scale reading is 25 and 26. So after including this head scale reading and pitch scale reading, let us write the value here. 2.26 is the reading shown here, and if you consider that error, it will come 2.28 millimeters. So while after including that error value, we got 2.28. Let us check the value. There should be no deviation. So that is the correct answer. So the thickness of the given glass plate here is 2.28 millimeters. Now let us apply the same procedure for wire also. So in order to check that one, we have to reset the device and we have to select wire and place the wire in between the stud and the screw and proceed the steps what we have done for measuring the glass plate, thickness of the glass plate. Once it is in contact, so let us observe the readings. Head scale reading is, pitch scale reading is 0. So write the value first, 0 point, and head scale reading is 60, 61, 62, 63. So head scale reading is 63, and if you include that error, you will get 65. So 0.65 millimeters is the thickness of the given wire. So let us check the value what we are getting here. So that is the correct answer. So readings of the given thickness of the given wire, what we have calculated using this simulator is 0.65 millimeters. So once we are getting the values like what it is shown in that video, you can tabulate the readings, and if you measure the length of this wire, it will be easy for you to calculate volume of the wire by using pi r square L. Thickness we calculated. From this thickness we can find out the radius. We got diameter and we can easily find out the radius. Once we are getting the radius, we can use pi r square L equation to find out this thickness volume of this given wire. Similarly, glass plate, we calculated the thickness of the glass plate, and if you measure the length and breadth of that glass plate, we can easily find out the volume of the glass plate using this screw gauge, and by using that equation L, B and H, length, breadth and height. So thickness we can measure, length and breadth we can measure using the scale, and after getting length and breadth we can easily find out the volume of the glass plate also. So proceed according to that aim given in your lab manual. So I hope you understood this procedure of measuring the thickness of glass plate and wire using this screw gauge. So students, I hope you understood today's practical session, screw gauge. So 2 experiments completed in this till this session. First one is vernier calipers in the previous class, and today we completed screw gauge. In the next class I will come up with another instrument. Till then, take care. Thank you.